Okay, I think we're in the middle of this problem. We got cut off. So I'm going to start reminding you what we've done, whoops, so far on this one. So first we factored the top, and I showed how to factor a trinomial that has a number in the front. So we did the AC method. So that's something you can look up if you know you need help remembering how to do that. So this is something that you should know how to do before pre-calculus. So we factored the top. The bottom could not be factored because it's a plus, not a minus one. So we'll start here. So this is what we got when we factored the top, and we cannot factor the bottom. So if I set the bottom equal to 0 and solve, I showed that here, we would get imaginary numbers, right? We would get a square root of a negative, which we can't do. So that's how we figured out there were no vertical asymptotes. For the horizontal asymptotes, since the powers are the same, they're both x squared, we take the coefficients out front. So 2 over 1. So that's how I got y equals 2. So this one has a horizontal asymptote, but not a vertical asymptote. And these usually end up graphing kind of funny. So sometimes we do cross the horizontal asymptote on these. So I would definitely suggest plotting multiple points. So I would maybe start with the x and the y intercepts. So if we plug 0 in for all of the x's, so I think I'm just going to make a chart here. So if I plug 0 in for all the x's, I end up getting -2 over 1. So that's one of my points. If I set this whole thing equal to 0, so if the y was 0, I would get +2 and -1/2. So 2, 0, -1/2, 0. I'm going to go ahead and just try 1 to see what's going on here. If I plug 1 in, I get 2 minus 3 minus 2 on top and 2 on the bottom. So -1, -3 over 2. So that's like here. And I'm going to go ahead and do another one. I'm going to maybe try -1. So if I plug in -1, I get 2 plus 3 minus 2 over 2. So +3/2. So you see, this is very different. And if you ended up doing more points, I think you'd end up seeing it went a little high over here, but it's still going to head towards that asymptote at the end. I think this one as well. So the best way to do these is to do as many points as you can. But this type is rare. You don't see it a lot. So for this one, first thing I'm going to do, top please, thank you. I'm going to try to factor the top or bottom if I can. So 5 and 3 can get me to 15, but can also get me to 2. I need 1 positive and 1 negative. So that's how it would work. So I almost can cross these out. If I could cross these out, that would mean there's a hole at that point. But since I can't, we do have a vertical asymptote at x equals -3. And for the horizontal asymptote, if the top is bigger than the bottom, that means there's none. And if it's exactly 1 degree higher, which is what we have here, it means there's probably a slant asymptote. So to find the slant asymptote, I need to divide. So remember how to do long division. We try to pick what would we have to multiply x by to match x squared. So that would just be an x. So x times x times 3, subtract, carefully subtract here. 2 minus 3 is a -1. And then we bring down the next term and we do it again. What would I have to multiply x by now to match this? Just -1. Multiply and multiply. Subtract, carefully subtract. This ends up being -15 minus a -3. So -12. But that's my remainder. So when you're finding your slant asymptote, you can ignore your remainder, and your line, your slant, is y equals whatever you got up there. So I'm going to graph x equals -3. And I'm going to graph my slant asymptote, which is just a line that starts at -1, up 1, over 1. So this is what a slant asymptote should look like, some kind of diagonal line. So my graph is still broken up into 4 pieces, just like we were doing before. It's just they're kind of slanted. So I would again try a couple points on one side of this vertical asymptote and then on the other side to see what's going on. So I'm not going to do many, but you guys should do more. If I just plug in zeros, an easy one, I would get -5. If I plug in 1, I get -3. So it's doing something like that. And then on the other side, if I plug in -4, I get 7. So I'm up here. So it does something like this. But again, if you guys give 2 points on this side and 2 points on this side, Alex will draw it for you. Okay, last one, word problem. We have a sports trainer has monthly costs of $70.76 for phone service and $43.86 for a website and advertising. So he pays these every month. In addition, a $15 fee is paid to the gym for each session in which the trainer works with the client. So he pays these 2 things every month, and then he pays this to the gym every time he works with a client. So what would his cost function be? Well, we need to add these 2 up. So I'm adding the 70.76 and the 43.86. So he definitely pays this, but he also pays $15 for each session. So we're just going to call X the number of sessions because we don't know how many. So this is his cost per month to be a trainer. Write a function representing the average cost for blank sessions. So to find the average cost for how many sessions just means, first of all, they put a line over it to show that this is the average cost. It's just the same thing you had before, but divided by however many sessions you have. Because then when you do your total cost divided by your total number of sessions, you're basically finding out how much does each session cost you. Okay, so this is the function for that. And now we're going to plug in some of these. Okay, so now we're going to plug in these numbers. So this is finding out what's the average cost if there was 5 sessions, what's the average cost if there was 30, and what's the average cost if there was 130. So you're just plugging these numbers in for X. Make sure you do the right order of operations. And if you thought these X's could cross out, they cannot, because this 15X is tied together with this. So you cannot do it. If it was just 15X over X, you could, because these 2 things are being multiplied. But when something else is being added or subtracted, that kind of locks it together, and you can't individually cross out one thing. All right, so I get 37.92 when I plugged in 30. I mean, sorry, when I plug in 5. Now I'm plugging in 30. And it gets smaller, which should make sense. The more sessions he has per month, the less it's going to cost him because he's going to be kind of offsetting that cost. And finally, I'm going to plug in 130, so it should get even smaller. But there's going to be a limit to how small it can get. $15.88. So it got smaller like we thought it would. So now the last question is, if the trainer can realistically have 130 sessions per month, because he can't have unlimited amount, right? However, if the number of sessions were unlimited, what value would his average cost approach? Meaning it's not going to keep going down and down and down until he has no cost, right? He's always going to have some kind of cost. What does this mean? So if we look at it kind of as a graph, because that's what we've been doing, this function is 114.62 plus 15x over x, right? If we were to graph this, there would be a vertical asymptote at 0, and there'd be a horizontal asymptote at 15. Do you see why? Because the highest power on the top and bottom are x. So even though this is in the wrong order, it's still the x. So 15 over 1 means wherever 15 is, there's an asymptote. So if we were to mark the points that we just found, right? When we plugged in 5, we got 37 something. When we plugged in 30, we got 18 something. When we plugged in 130, we got 15 something. That all makes sense because we have this asymptote. So it's going to just get closer and closer and closer to 15, but never quite get there. So that's what they're asking us. The bigger and bigger the x's get, what number are we approaching? We're approaching $15 per session, which happens to be the same as the fee paid to the gym in the absence of the fixed cost. Remember, what did he have to pay? He had to pay that fixed cost for the phone and the website plus $15 per session. So the more sessions he does, he's only paying that, and it's kind of wiping out his fixed costs. So if the only thing he's paying is $15 per session and he's charging people like 130, he's doing pretty good. All right. Sorry about the interruptions. That's the end of 2.6.